Today we're going to be talking about factoring out the greatest common factor, or what we're going to call the GCF. So this means that we're going to find the biggest number and or variable that all of the terms have in common. So we're looking at all of them, whether it has 2 terms, 3 terms, 12 terms, whatever it's got. We're going to look for the biggest number and or variable, I guess I should even say variables, that they all have in common. So if we have 4x to the third plus 12x to the second minus 8x, we want to see what the greatest common factor of the GCF is. So first thing I'm looking at here, we have 4, 12, and a negative 8. So the first thing to do is look at all of those numbers. Well, what do those have in common? So they all have a 4 in common. 4 is a factor, the biggest number that goes into all 3 of those things. Then what we're looking at is the variables. So x to the third, remember that means that we have x times x times x, and x squared means x times x, and x is just itself. So we're looking for how many x's we could take away from each of those at the same time. So we have, if we take away 1x here, 1x here, and 1x here, so we know that they all have 1x in common. Can I take another x away from all of them? So if I take an x away here and an x away here, do I have another one to take away? I do not. So that means that we have to figure out what's left inside now. So we had 4, we divide that by 4, we get 1. If we had x to the third and we got rid of an x, we still have 2 x's there, which we write as x squared because that's x times x. 12 divided by 4 gives us 3. We had 2 x's, we got rid of 1, which means we have 1x left. Negative 8 divided by 4 is a negative 2. We had 1x, we got rid of 1x, we don't have any x's left. So if we're looking at this, now, do we really need to put this 1 here? No, but if it helps you, that's fine. We're looking to make sure there's nothing else that this parentheses has in common. So if we're looking at x squared plus 3x minus 2, do they all share something in common? No, they don't. So this would be our answer. And the way you're going to double check that is if you distribute this 4x back in, you should get the original question. So 4x times x squared would give us 4x to the third. 4x times 3x would give us 12x squared. And 4x times negative 2 gives us negative 8x. So this is our answer. Okay, so let's take a look at another example. So if we have 3y squared minus 18, okay, again, we're going to look at our numbers first. So we're looking at 3 and negative 18. The biggest number that goes into both of those would be 3. Here we have y squared, and this doesn't have any y's, so they don't have any variables in common at all, so the 3 is it. 3y squared divided by 3 would give us just y squared, because 3 divided by 3 is 1, and we had y squared and we didn't get rid of any y's, so that leaves us y squared. Negative 18 divided by 3 would leave us with a negative 6, and that's our answer. We could distribute that back in and double check it. So 3 times y squared is 3y squared. 3 times negative 6 is negative 18. So we are good to go. Okay. See if we can get this here. So what happens if we have 8x squared minus 12x? So here, 8 and 12, negative 12. The biggest number that goes into both of those is 4. X squared and x, so x squared means we have 2 x's, x just means we have 1, so we could take 1x away from both of them. 8 divided by 4 is 2. We had x squared, we got rid of an x, so that leaves us with 1x left. Negative 12 divided by 4 is a negative 3. We had 1x, we got rid of it. 2x minus 3, there's nothing else left inside that they have in common. So there's our answer. Okay, let's take a look at 15p to the third minus 10p squared plus 25. So if we're looking at all three of these numbers, 15, negative 10, 25, the biggest number that goes into all of those is 5. If I have p to the third and p squared, this one doesn't have any p's. So be very careful here. You're going to be tempted to say, oh, well, these two have things in common. Remember, you have to look at all three terms. So 5 is the only thing they have in common since this last term doesn't have any p's, no variables with it. All right, 15 divided by 5 would be 3. We didn't get rid of any variables, so we have to keep everything that we had. Negative 10 divided by 5 is negative 2. Again, keep the variables because we didn't get rid of any. 25 divided by 5 is a positive 5. The inside piece, inside the parentheses, has nothing else in common. So there's our answer. Remember, you can always check your answers if you distribute them back in as well. It's a pretty good check. All right, last question here. We have negative 20y to the 6th plus 12y to the 4th minus 8y squared. So looking at negative 20, 12, and negative 8. Whenever this first term is a negative, whenever your leading coefficient is negative, you're going to bring a negative out as part of your GCF. So 20, 12, and 8 all have a 4 in common. So we're going to say negative 4 is part of our GCF. We have y to the 6th, y to the 4th, y squared. That means that we can take 2 y's away from each of them. So that means negative 4y squared is our GCF. Now be careful when this is a negative, because negative 20 divided by negative 4 changes this to be a positive 5. If we have y to the 6th and we got rid of 2 y's, that means we would have y to the 4th left. 12 divided by negative 4 is a negative 3. We had 4 y's. We got rid of 2 y's. So that means we're going to have 2 y's left. Negative 8 divided by negative 4 is a positive 2. We had 2 y's. We got rid of 2 y's. So there's no y's left. Okay. So there's our answer. So with these, remember, you're looking for the biggest number and or set of variables they all have in common. If you need to, like we did at the very first example, you can write out that this is 6 y's or 4 y's and 2 y's, so you know exactly how many you can take away. But obviously we want to be building that pattern of knowing without writing all of those things out, what they have in common. And then you're going to divide your numbers. Okay, divide the coefficients by the GCF number. And then with our exponents, we're going to subtract them. Okay, you can always double check by distributing it back in and making sure that you get the original question. And that's it.